Welcome to the Meteorology Matters podcast.
Great to be here.
Today we're looking at some, well, frankly unsettling weather patterns, focusing particularly on Florida right now.
Yeah, the situation down there is pretty dramatic.
We're seeing extreme heat in the coastal waters. I mean, there was that report of ocean temperatures hitting nearly 98 degrees Fahrenheit in Everglades National Park recently.
98 degrees, that's something you'd maybe expect in peak July, not late May.
Exactly. So today, we want to really understand this marine heat wave. What's causing it? What are the impacts right now on weather, on ecosystems?
And crucially, what it might signal for the upcoming hurricane season,
Mm-hmm.
especially given the patterns we've seen lately with powerful storms.
Okay, so let's start with the heat wave itself. It's affecting waters near Florida, the Caribbean, the Bahamas. What exactly defines a marine heat wave?
Right. So basically, it's a large area of the ocean where the water temperatures stay well above average for, an extended time.
And the current situation is rated pretty highly.
It is. The data we're seeing shows conditions rated as strong to severe. That's a level 2 or 3 on the Coral Reef Watch Scale from the National Oceanic and Atmospheric Administration, or NOAA.
And those specific temperatures, they just seem unreal for this time of year.
They really are. That nearly 98-degree reading, that was near Buoy Key in the Everglades. And even this week, it was still around 97 degrees there.
Wow.
And this isn't just one spot. It stretches from Florida's Big Bend area southward right through the Keys.
The main thing is just how hot it is and how early it is.
Precisely. These are temperatures we'd normally associate with much, much later in the summer.
And one of the most immediate and frankly tragic impacts is on the coral reefs.
Yeah, absolutely. The bleaching alert levels are very high. We saw severe coral bleaching in Florida back in 2023.
I remember that. It was really bad.
So bad that NOAA actually had to extend its severity scale because the existing one just wasn't enough.
That's incredible.
And if you look at the long-term data near Buoy Key, you see this steady warming trend in the sea temperatures going back to 2023. It's not just a blip. It's persistent.
Is this heat just around Florida or are other areas feeling it too?
No, it's definitely not isolated. Reports show similar strong to severe marine heat waves in the western Bahamas, around Cuba, Jamaica, Haiti.
So a wide area.
A very wide area. And even closer to home, near Pensacola, Florida, and along the Texas coast from Galveston down to South Padre Island. Again, you're seeing water temperatures more typical of July.
So the takeaway is that a huge chunk of the Gulf and the nearby Atlantic is just loaded with this extra heat energy.
That's exactly right. Primed.
Okay, so it's clearly affecting marine life. But how does this superheated water translate to the weather we feel on land, especially near the coasts?
Well, you can think of these hot ocean areas as like a local heater for the atmosphere right above them.
Oh.
They pump a lot more moisture and heat energy into the air. And that can help lock in unusually high air temperatures and really high humidity levels over land nearby, sometimes for weeks.
We've definitely felt that heat in the southern states, even while it's been cooler elsewhere.
We certainly have. While the north has had different patterns keeping things cooler, the south has been baking, and that's directly influenced by this marine heat.
The number of records is staggering.
It really is. Just this month, over 4,000 daily record high temperature reports across the U.S. That's more than double the number of record lows being set.
4,000, wow. Any specific examples that stand out?
Oh, definitely. Tampa just had its hottest May morning on record. Records go back to 1890 there last Thursday. The low temperature was 80 degrees Fahrenheit.
Meaning it never got cooler than 80 overnight.
Exactly. And Fort Lauderdale set a similar kind of record, their highest May minimum temp at 82 degrees on Monday. Even Houston, with records since 1889, set 7 new overnight warmth records this month, including a new monthly record low of 82.
So the nights just aren't cooling off. That's tough.
Incredibly tough for people, for agriculture, for everything.
And alongside the heat, the humidity has just been oppressive.
And that's a direct result of the warm water. You get much more evaporation off these hot ocean surfaces.
Right.
That adds a tremendous amount of moisture to the lower atmosphere. So you end up with this unusually high humidity for May. And we're seeing the effects of that moisture plume stretching way up the East Coast, even up towards Maine.
And all the extra moisture in the air, that's like fuel for storms, isn't it?
Precisely. It's like adding high-octane fuel to the atmosphere. It significantly boosts the potential for heavy downpours and strong thunderstorms.
And the forecasts reflect that risk.
They do. We're seeing forecasts showing a high chance of heavy rain and intense storms across the southern and eastern states. That happens when this warm, really humid air clashes with any cooler, drier air moving in from the north or west.
We've already seen some pretty nasty storms pop up recently.
Yeah, there have been examples like golf ball-sized hail in places like Vero Lake Estates in Florida and also down in Austin, Texas.
So the risks are real.
Very real. The forecast risks include things like isolated tornadoes, damaging street-line winds, large hail, and critically, flash flooding because of the sheer amount of moisture available.
You mentioned the moisture, the fact that a warmer atmosphere can hold more water vapor overall. Does that automatically mean any tropical system that might form would be rainier?
That's a key point, yes. A fundamental principle of physics, really. A warmer atmosphere can hold significantly more moisture.
So more fuel for rain.
Exactly. Which means any tropical system, hurricane or tropical storm that develops in this environment has the potential to dump much, much more rain than it might have decades ago.
And that increases the inland flood risks, sometimes far from the coast.
Dramatically. Often hundreds of miles inland. We have research, like from David Keelings at the University of Florida, documenting this. His work shows an increase of about 25 more extreme rain events happening in Florida each year now, compared to 50 years ago.
And all that extra rain makes the ground soggy, which causes other problems too.
Right, you get these increasingly saturated soils from rainier seasons overall that weakens tree root systems, making them much easier to topple by wind. Even winds that aren't quite hurricane force can bring down a lot more trees if the ground is waterlogged.
Like we saw with Hurricane Milton last year.
That's a good example. The winds were destructive, but the already saturated ground made the tree damage significantly worse in many areas.
Okay, so we have these incredibly hot oceans impacting daily weather with heat, humidity, heavier rain. Let's pivot now to what this means for hurricanes specifically. There's a pretty direct link between hot water and storm power, isn't there?
Oh, absolutely fundamental. Tropical cyclones are like heat engines. They draw their energy, their fuel for wind, directly from the ocean surface heat.
So warmer water equals more fuel.
More fuel available, which means storms can potentially spin up faster, reach higher maximum wind speeds, and, maybe most importantly, intensify more rapidly.
Right, I've seen analysis suggesting warmer waters really boost the chances of that rapid intensification.
That's what the data shows. One analysis found warmer ocean temps increase the odds of a storm undergoing rapid intensification by about 50%.
50%, wow.
And if you look back over the last 40 years or so, most tropical cyclones that rapidly intensified did so when they were over abnormally warm water.
And just to remind listeners, rapid intensification is that scary scenario where a storm suddenly gets much stronger very quickly.
Exactly. It's defined as an increase in maximum sustained winds of at least 35 miles per hour in just a 24-hour period. It can turn a, maybe manageable storm into a potential catastrophe with very little warning time.
Which is terrifying for people in the path.
It really is. There's a quote from Jeff Masters, a well-known hurricane scientist who used to be with NOAA, where he said something like, anything loose in the Gulf is going to basically have double the damage potential it used to compared to 100 years ago.
Double the damage potential. That really underscores the risk from warmer waters.
It does, and the stats support this connection. Nearly 3 out of every 4 major hurricanes Category 3 or higher that formed in the Atlantic or Gulf, they traveled over record hot waters at some point.
And looking just at the Gulf Coast landfalls.
Over the past 25 years, fully half of all the hurricanes that made landfall on the Gulf Coast were major hurricanes at the time they hit land. That's a really striking statistic.
You mentioned the Gulf. Why is the Gulf of Mexico warming so much faster than other oceans?
It is. The Gulf is warming at roughly twice the rate of other global seas. And all that extra heat content is acting as high-grade fuel for storms entering the basin.
And these marine heat waves, like the one now, are becoming more common there.
They are. While tracking them systematically is relatively new, maybe since the 1990s, they've definitely become more common and more intense since then, especially in the Gulf.
And when a storm encounters one of these heat waves, that's when the rapid intensification risk really jumps up.
The analysis strongly suggests that. Some scientists started measuring these heat waves. About 2 out of every 3 rapidly intensifying storms pass through one of these hotspots.
And more recently,
over just the last decade, the link is even tighter. All but 2 storms that rapidly intensified traveled over unusually warm waters. The takeaway is clear. These marine heat waves are a key ingredient for the most dangerous aspect of modern hurricanes, their ability to suddenly explode in strength.
And it doesn't take a huge temperature difference to matter, does it?
No, it doesn't. The data shows the average ocean temperature was about 2 degrees Fahrenheit higher, where storms rapidly intensified compared to other parts of their track. And remember, even just 1 degree Fahrenheit above average can seriously harm marine life like coral. So these seemingly small temperature bulks have really big consequences.
We've also seen more of the most extreme storms, Category 5s, recently.
That's another really concerning trend. Nearly half of all recorded Atlantic Category 5 hurricanes over the last 40 years have actually occurred just in the last decade.
Half in the last 10 years.
Yes. And every single one of those recent Cat 5s underwent rapid intensification. And 4 out of the 5 happened over record hot waters. It strongly suggests the ceiling for hurricane intensity is rising.
So are experts starting to talk about a new era for hurricanes, particularly in the Gulf?
Some are, yes. Jeff Masters, who we mentioned, has said, it's quite possible we've entered a new era of increased hurricane activity in the Gulf of Mexico. And he added, certainly we have reached a new era of activity for more intense storms.
More intense storms seems like the key finding.
It does. And Sam Lillo, another researcher formerly with NOAA, made the point that this warming basically shifts and widens the windows of opportunity for storms to strengthen.
So just to summarize that point based on the research, warmer waters clearly link to more powerful storms, but the evidence isn't as strong that they cause more storms overall.
That seems to be the consensus in the sources, yes. The most robust connection is to intensity, making the storms that do form potentially much stronger rather than necessarily increasing the total number of storms each year.
Let's go back to that striking pattern you mentioned, the Gulf Coast seeming like a bullseye recently. Why have almost all major hurricane landfalls hit the Gulf since the late 90s?
It's a really remarkable statistic when you look at it. Since 1999, there have been 18 major hurricane landfalls on the continental U.S. All but one of them were on the Gulf Coast.
All but one in over 20 years.
And the trend is even more stark recently. Since 2017, all 10 major U.S. landfalls have been on the Gulf Coast. That includes 6 hitting Florida, with Milton and Helene last year being the latest.
An 8-year streak of nothing but major Gulf landfalls, is that unprecedented?
In terms of frequency within that time frame, yes. It appears unprecedented in the historical record, even more frequent than an active period back in the late 1940s and 1950s.
Does the Gulf's shape play into this?
It certainly contributes. The Gulf is relatively enclosed, right? It's not wide open like the Atlantic. So once a strong storm gets into the Gulf, there's less distance and less time over water for it to potentially encounter unfavorable conditions like wind shear or dry air that could weaken it before it hits land. It's sort of geographically constrained.
Are there bigger atmospheric patterns influencing this Gulf focus, like El Nino or La Nina?
Experts definitely think so. Large-scale patterns like the El Nino Southern Oscillation, or ESO, play a big role. Specifically, La Nina phases tend to create conditions in the Atlantic basin that are more favorable for hurricanes.
How so?
During La Nina, you typically get less vertical wind shear. That's the change in wind speed or direction with height that can tear storms apart. You also tend to get less dry, sinking air. Both factors help storms develop and intensify.
And La Nina can steer storms differently, too.
Yes, that's crucial. La Nina can shift the position and strength of the jet stream in a way that tends to steer storms more towards the U.S. coastline, and often specifically towards the Gulf of Mexico.
And we've had a lot of La Nina recently, haven't we?
We have. Surprisingly frequent and long-lasting La Nina events in the Atlantic over the last 7 years or so, pretty much every season except 2. That's surprised some scientists and has likely contributed significantly to these steering patterns favoring the Gulf.
So is this Gulf bullseye pattern purely natural cycles like La Nina, or is climate change playing a role in the steering, or maybe a combination? What do the sources say?
That's where there's still some scientific uncertainty. 8 years is a very noticeable streak, but in climate terms, it's still a relatively short period to definitively say it's a permanent shift driven by climate change alone.
Okay.
It's possible that climate change could create atmospheric conditions that mimic some La Nina effects, potentially making Gulf landfalls more likely over the long term. But predicting specific storm tracks years out based on climate change is still really challenging.
So, not a sure thing yet.
Right. Jeff Masters pointed this out, saying he wasn't totally convinced this 8-year run is the new normal. He recalled that Florida went a whole decade, from 2006 to 2015, without any hurricane landfall, let alone a major one.
That's a good point. Things can shift back.
Patterns can definitely shift. However, it's also worth noting that forecasts suggest we might be heading into another La Nina this hurricane season. So those favorable conditions for Gulf storms could continue. at least in the near term. The takeaway is the intensity link to warming is strong, but the specific location link over just 8 years is less certain, could be natural variability amplified, could be something more.
Okay, so looking forward, putting it all together, what's the consensus from the data and experts on the future of hurricanes in a warmer world?
The confidence is very high on 2 key points. Tropical cyclones are expected to become more intense, and they are expected to become significantly wetter.
And we know water is the biggest killer in these storms now.
Increasingly so. Rainfall flooding has become the deadliest aspect. Data from the last decade shows it caused nearly 60% of all U.S. hurricane-related deaths.
And storm surge isn't going away either, especially with sea level rise.
Exactly. Storm surge, the water pushed ashore by the storm's winds, will be riding on top of higher baseline sea levels. That amplifies the reach and depth of the flooding.
You mentioned Florida's west coast could see significant sea level rise.
Projections suggest over a foot of sea level rise there by 2050, even under more optimistic scenarios. That puts vastly more people and property at risk from surge, including many who live outside the current designated evacuation zones. You saw the impact of surge from Helene in Pinellas County last year. Imagine that same surge starting from a baseline that's a foot higher.
Yeah, that's a sobering thought. And the rain threat just compounds things further.
It does. Because that warmer atmosphere holds more moisture, hurricanes are literally carrying more water. That means higher rainfall totals, leading to more widespread and dangerous inland flooding.
Affecting areas far from the coast.
Right? Areas that maybe don't think of themselves as being in a hurricane zone can suddenly face life-threatening flash floods. People might be less prepared. Evacuation routes might not be designed for that kind of water.
We saw tragic examples of that rainfall flooding recently.
We did. Helene caused flooding deaths while inland in the Carolinas and Georgia and also in Florida. And Hurricane Milton last year produced truly historic rainfall in Tampa Bay. Parts of Pinellas and Hillsborough counties got around 17 inches in just 5 hours.
17 inches in 5 hours.
Unbelievable amounts. It completely overwhelmed stormwater systems, flooded inland neighborhoods that hadn't flooded like that before. Some analyses put rainfall rates in certain spots at 1 in 1,000-year levels.
So, hotter water means stronger storms, warmer air means wetter storms.
It leads to the conclusion Jeff Masters summarized. The extremes will get more extreme. It really suggests that while hurricanes might feel more routine in some ways because of recent frequency, the ones that do hit could be significantly more formidable, primarily because of the increased water threats, both surge and rain.
Okay, lots to think about there.
Definitely. Which leads to a provocative thought for you, the listener, to mull over. If the Gulf of Mexico's geography makes it something of a natural trap for storms, especially intensifying ones, and if warming oceans are clearly boosting the potential for that dangerous rapid intensification, what does that really mean for how we all need to prepare? Not just if you live right on the beach, but maybe hundreds of miles inland, facing unprecedented rainfall and rivers overflowing because the ground is already soaked. How does that change your calculus?
A really important question. That wraps up this edition of the Meteorology Matters podcast. We hope this look at the marine heat wave and its connection to our weather and future hurricane risks has given you some valuable insights.
Thanks for joining us. For more weather insights and updates, you can follow meteorologist Rob Jones on Instagram. His handle is Meteorologist. You can also find him on TikTok under TV Meteorologist. And on YouTube, just search for Rob Jones Hurricane. That's where you can also find the Meteorology Matters podcast playlist with our other deep dives.
Thanks again for listening. Join us next time as we continue to explore the forces shaping our world.